Have you ever wondered how geckos are able to climb up walls? Are their feet equipped with mini suction cups? Are they born with physics-defying superpowers? Or is there something else going on? Well, it turns out the secret to their success is actually a simple force called friction. But what exactly is friction? And how can these creatures use it to seemingly do the impossible? Well, strap in everybody, because these are the questions that we're going to be answering today.
Friction is a force exerted between two objects when they touch or rub together. It tries to prevent the objects from moving and always acts against the direction of motion. Friction is what allows you to climb a hill without sliding right back down to the bottom, what makes Velcro stick, and what makes a ball slow down after you kick it.
Now, the first thing you need to know about friction is that there's actually two types. There's static friction and kinetic friction. So static friction occurs between two objects that aren't moving, like your couch sitting on the floor. It's why if you lightly bump into your couch, it doesn't start to move. The friction between it and the floor is too great.
But static friction can only do so much, and eventually, if you push hard enough, your couch will start to move. Once the couch is moving, kinetic friction is at work, trying to slow down your couch to a standstill again. Kinetic friction explains why, if you stop pushing the couch, it won't just keep sliding across the living room, but instead will quickly come to a stop again.
But how do these forces of static and kinetic friction really work? In order to understand that, we're going to have to zoom in and look at things on a much, much smaller scale. In fact, we're going to have to zoom all the way down to the tiny little microscopic molecules that actually make up your couch.
The molecules within your couch are made up of tiny positively and negatively charged particles. You may have heard the saying that opposites attract, and well, that's actually true for charges as well. The positive and negative particles within the molecules attract each other. Overall, the number of each of these particles is the same, which is why your couch as a whole doesn't attract the objects around it. But on the small scale that we're looking at, there are regions with greater positive or negative charge.
So when two objects touch, like your couch and the floor, these tiny regions of positive and negative charges attract each other and cause the objects to stick together. The more of the object's surfaces that are in contact, the more of these small attractive forces there will be. And these attractions, commonly referred to as van der Waals forces, are the main source of static friction. These van der Waals forces, they aren't very strong though. So, of course, if you push hard enough on your couch, these bonds can be broken and the couch is gonna start to slide. So, how does kinetic friction make it slow down again?
Well, it turns out that the surface of any object, no matter how smooth it seems, is actually very rough and uneven if you zoom in closely enough. The surface will be full of miniature mountains and crevices, and when two objects are sliding against each other, these mountains will keep slamming into each other. Every time the surfaces collide, a little bit of energy is lost to heat or sound, making the object slow down and eventually come to a stop.
So, how do geckos use friction to climb walls? They actually take advantage of van der Waals forces and static friction that we talked about earlier. Geckos' toes are covered in hundreds of tiny microscopic hairs called setae. Each seta then actually splits off into hundreds of even smaller bristles called spatulae. Each one of these tiny spatulae presses against the surface they're trying to climb, creating thousands and thousands of locations for van der Waals forces to induce static friction.
Now, at this point you may be thinking, I could press my fingers to a wall too, so how come I can't climb up walls like a gecko? The gecko's secret lies in the number of spatulae they have on their toes. These spatulae create many more points of contact between the gecko's feet and the wall than we could ever hope to achieve by just pressing our own fingers into a wall.
So there you have it. Geckos don't have superpowers that defy the laws of physics. However, they are super good at taking advantage of one of nature's very cool properties, friction.
Let's quickly recap what we learned about friction today. We learned that there are actually two types of friction, kinetic friction and static friction. Kinetic friction acts between moving objects and is caused by microscopic collisions on their surfaces as they slide against each other. Static friction acts on stationary objects and is caused by small regions of positive and negative charges within the objects attracting each other. Both of these come together to create friction as we know it in everyday life, the force that slows stuff down, makes stuff stick, and even lets geckos defy gravity.
Created using Powtoon.